Hey y'all, Miss Harper here for our intro to quadratic notes. All right. So we've actually been working with these quadratic functions. You can go ahead and write this standard form right here, y equals ax squared plus bx plus c. So all of those quadratic functions that we've been factoring, now we're going to start graphing and talking more about those figures. So quadratic functions are nonlinear and form a U shape. We call this shape a parabola. It can either open up or down. There are several key features to a parabola. Use the chart below to describe the key features of the following quadratic function to the right. All right, so what we're going to do before we skate down here, we're actually going to go ahead and label some of these parts on our graph. First thing, some easy ones that we already know about. This guy and this guy. We call those x-intercepts. All right, x-intercept, x-intercept. We'll learn about some other terms or names that we also call those things, like a zero, which we talk about a lot. This also happens to be a y-intercept as well, because it's also crossing through the y-axis. This piece right here, we call this the vertex. Vertex. All right, and that's the turning point of your parabola. It's either going to be the highest point or the lowest point. So we describe it by calling it a maximum or a minimum. All right, let's see that. And we got one more fun little thing, and that is this thing we call the axis of symmetry. And so as you can see, it cuts this parabola straight down the middle. It's a symmetrical figure here, so we abbreviate it by calling it the AOS. All right, so let's go ahead and slide down here and talk about some more of these key features. All right, so first thing, positive or negative. So what does it mean? Basically, it means if it opens up or down. All right, so if the value of this a right here, if a is positive or greater than 0, then it's going to open up. And if a is negative or less than 0, it's going to open down. So this is how we write these things. All right, so positive makes a smiley face, and negative makes a sad face. It opens down, and so this would be our negative graph right here. Alrighty. Intercepts. So we just talked about some of our intercepts. We have some different ones happening. So what does it mean? It means where graph crosses x and y axis. Okay. So for our x-intercepts, x-int, remember that's always going to be some number for x and then 0 for y. And for our yint, our y-intercept, it's always going to be 0 for x and some number for y. So looking above at our graph, we can list out a couple of those, and actually we had two x-intercepts here. So our first one's at 0, 0. They're at the origin. Our other one's at 1, 2, 3, 4, 0, 4, 0. And then our y-intercept also happens to match up with one of the x-intercepts because of the origin, and it's also at 0, 0. But we already know about those parts, the intercepts. All right, so next bit, these three parts are actually all related. Okay, so I'm actually going to start here with the vertex. All right, so the vertex is the turning point of the parabola. All right, it's the highest or the lowest point. So it is, if you want to draw a little picture of that, it's going to be this or this. Okay, that turning point. So our vertex on our graph is over 2, down 1, 2, 3, 4. So 2, 4 is our vertex. 2, 4 is our vertex. Now what does it have in common with the max or the min? Well, okay, so for this particular case, for maximums and minimums, we don't usually write them as a point. It's a way that we describe our vertex. So it'll say, what is your vertex? And it says, is this a maximum or a minimum? Sometimes it'll ask for like, what's the maximum point here or whatever, and you just describe that vertex as a point. So your maximum happens whenever you have a negative parabola. Negative parabola. And it's the highest point. Highest point. All right, so again, our vertex describes that. And if it's a minimum, it's just the opposite, and it's the lowest point. It's a positive parabola. And it's the lowest point. All right, so in this case, do we have a maximum or a minimum? Well, we have a minimum. All right, so we don't have this. I'm going to say none. And our minimum is, we would just say minimum. Again, it asks, what is your vertex? And it says, is that a maximum or a minimum? And we say minimum. Okay, then we talked about that axis of symmetry. So that was that little dashed line that we drew down our parabola. So here is the axis of symmetry. All right, and it cuts right through the vertex. All right, so this divides parabola in half. And we do describe it as a vertical line, so you should be thinking vux. It is a special x equals some number, okay? So in this particular case, you'll see it always corresponds to the x value of your vertex. So if I go back and look up here, it's x equals, and wherever it cuts through my x-axis, which is right here at 2. All right, and again, x equals 2, we do have to write this as an equation. It says this must be written as an equation, not as a number. And again, it's always going to be the x value of your vertex because it cuts right through your vertex. All right, and then the last thing, we got some new terms here. We're actually familiar already with zeros. We know what those are. So go ahead and write down this. It's called ROXS, R-O-X-S. But that 0 actually represents a 0. So R for roots, 0 for zeros. And then I would put x-intercepts in here. And then solutions. So roots, zeros, x-intercepts, and solutions. And they all mean the same thing. It all means where the parabola crosses x-axis. Okay, so that would look something like this. Let's see, here's my graph. We got one right here and one right there. Okie doke. And again, we already listed both of those out. We had 0, 0, and 4, 0. So basically, it's literally all the same thing. They mean the exact same thing. They just have a bunch of different words for it, which I also think is ridiculous. We do need to add 2 more bits of our notes. Just squeeze it down here at the bottom. First thing is domain. All right, so remember that your domain represents the x values that your graph is going to contain. For this case, if we go back and look at our parabola, all right, this is an arrow right here, and this is an arrow right here. So remember, this is what we call a continuous function. It is some graphed line of sorts. So can I mark the furthest left? No, because that's going on to infinity. Can I mark the furthest right? Also no, because it's going to infinity. So what we call our domain is all real numbers. Okay, and for our purposes, all real numbers. All of our quadratic functions for Algebra 1 will always be, the domain will always be all real numbers. Now remember, you can also use this symbol right here. It is an R with 2 downstrokes, and that represents all real numbers. So that's the domain for this graph. And then we'll talk about our range real quick. Our range is the set of all y values contained on your graph. And for our range, it's going to be one of two things. It'll be, let me say this. You want to write these two things down. There's going to be two options here. So if it opens up, it's going to be y is greater than or equal to some number, whatever this number is down here. All right, and if it opens down, it'll be y is less than or equal to whatever number is right here for your y values. All right, so in our case, if I scroll back up here, okay, can I mark the lowest point? Yes, it's here at -4. Can I mark the highest point? No, because we have these circles and it's going on to infinity. So we can say I have anything greater than or equal to 4. So my range for this graph is y is anything greater than or equal to 4. And now a fun fact, this number will always be related to the y value of your vertex. Okay, see that 4? Those are the same 4s that we're talking about. All right, go ahead and flip over to the back real quick. Okay, I am going to leave you to do these on your own. So what I'm going to do is I'm going to pause this note video. I'm going to fill in all the answers. I want you to fill in your example 1, 2, and 3 on your own and practice, and then you can unpause your video to check your answers and see if you're on the right track. Alright, so here's your answers for examples 1 and 2. This one was pretty easy. The most common mistake that I see is the range. So remember, you can't mark the lowest point, but we can mark the highest. And then you just need to ask yourself, do I have a graph that is greater than 4, or do I have a graph that's less than 4? In which case we have it all less than or equal to 4. On example number 2, common mistake that I saw was the axis of symmetry. Alright, so that's cutting down right here, and remember you're trying to see where is it cutting through the x-axis, and that is at -1 there. And then it only has one solution this time. It just touches the x-axis and then bounces right back off. Sometimes we'll have no solution. Sometimes the graph just doesn't touch it. For example, what if it looked like this right here? Okay, and it just doesn't touch it? Well, then that just means you would have no solutions or no x-intercepts. Okay, and then our last one here. See, most common mistake I saw for this one, again, is the axis of symmetry. So again, kind of tricky, but you got to think, where is this cutting through my x-axis? Well, this is 2 on my x-axis, this is 1 on my x-axis, and this would be 0 on my x-axis. All right, and don't forget, it also is the x value of your vertex. And then again, we have values less than 4, less than or equal to 4. And I guess that was another mistake I saw up here on the range. Okay, again, talking about our y-axis, well, I'm here at 0 on my y-axis, and I have anything greater than or equal to 0, which is our range. All right, go ahead, and you should have a practice assignment to finish up with this. You have 12 problems on there, and don't forget that is due for a grade.